16 squared times 25 squared. Piece of cake. 16 squared, that's 256. 25 squares, 25 times 25, that's 625. Hey, check that out. These two numbers have the same digits, just in a different order. That's pretty cool. Of course, it's not very helpful. I don't want to multiply these two numbers out. That'll take too long. Let's find something smarter to do. I'll start by writing out these squares as products. This is 16 times 16 is 16 squared. 25 squared is 25 times 25. Now I can reorder these terms any order I want to. Won't change the product. So what I'm going to do is I'm going to group a 16 and a 25 because those two are easy to multiply. And that leaves another 16 and another 25. Hey, check this out. We just have 16 times 25, that product, times itself. Multiply by a number by itself, you get a square. So that's just 16 times 25, that product, squared. 16 times 25 is easy. That's 400, because if you take the 16, that's 4 times 4. 4 times 25 is 100, so this is 4 times 100, which is 400. And 400 squared is 160,000. You just take the 4, square the 4, and slap on the 4 zeros at the end. Look at what we did here. We started off with the product of squares, 16 squared times 25 squared, and we ended up with the square of a product, 16 times 25. And we could have gone the other way. We could have started with 16 times 25, that product squared, and gone back to a product of squares. And that's kind of what we did with the 400 squared. When we squared 400, we thought of that as 4 times 100 squared. So that's 4 squared times 100 squared. The 4 squared is the 16, and the 100 squared is 10,000. That's where we get the 4 zeros. 4 squared times 100 squared is 160,000. Now, if you look back at this, there's nothing really special about the 16 and the 25, where we went from here to here, or about the 4 and the 100 going from here to here. We should be able to do this with any two numbers. Let's take a look at that. Some product, any product, a times b, we're going to square that. Well, to square that, we just multiply it by itself. ab times ab. Now, of course, we can reorder these. We put the a's together, AA, put the b's together, BB, and we get a squared times b squared. Now, what about longer products? What if we have a product of three things? We start with a times b times c squared. Well, once again, square, we just multiply by itself. ABC times ABC. We can reorder this, group the a's, group the b's, group the c's. AA, BB, CC. And sure enough, we get a squared times b squared times c squared. So we take the square of a product of three numbers, get a product of three squares. Now, of course, we can go on with 4 or 5 or 6. You take a product of 6 numbers, you'll get and square that, you'll get a product of 6 squares at the end. But wait, there's more. Is there anything special about squares? What if we do this with cubes? Take a product and cube it. Well, that just means multiply 3 copies of the product. So AB times AB times AB. And just as before, we can reorder this. We can group all the A's, A, group all the B's, B, B, B. And sure enough, we get A cubed times B cubed. Cube a product, you get a product of cubes. Works for squares, works for cubes, should work for any positive integer power. If we take the product AB, raise it to some positive integer power, n copies of AB. We multiply these together. We have n of these. We're multiplying them all together. Of course, you know the drill here. We regroup everything. We put all the a's together. There are n a's here, so when we group all of them up, we get a to the n. When we group all the b's together, well, there are n of them, we get b to the n. And sure enough, the nth power of a product is a product of nth power. So we see that raising products to powers works pretty much the way we would expect it to. So you know what's coming up next. We're going to raise quotients to powers.